density factors. A can of Diet Cola will float, and a can of regular cola will sink when placed in water. You see, in the same amount of fluid ounces, there are more atoms in the can of regular cola. The main ingredients in cola are carbonated water and sugar. So each can has the same amount of water molecules, but in the same space, the regular cola has additional molecules from the sugar. Putting more atoms in the water forces the molecules to be more dense, making the cola sink. Hot air balloons fly because of density. Just like all matter, air is made up of atoms and molecules. When air inside the balloon is heated, it expands or gets bigger. So, compared to the air around the balloon, the atoms inside have more room to move around and, as a result, are not as tightly packed together. The air inside the balloon is less dense than the surrounding air, and the balloon becomes buoyant. When it's time to land, the pilot stops heating the air, and as it cools, it contracts to match the density of the surrounding air. The effects of gravity go to work and bring the balloon down to Earth. If an object is cut in half, its density remains the same. Take a look at a gold coin, made of neatly arranged gold atoms. When cut in half, the tightness of the atoms does not change. Whether you have a half of a coin or a complete gold coin, the density stays the same. The density of liquid water is 1. Objects with a density of less than 1 will float, and objects with a density greater than 1 will sink. Take a look at these 3 objects. All of them float, so their densities are less than 1. But if you take a closer look, you see that as density increases, more of the block is below the waterline. Scientists have figured out the density of a block converted to a percentage is equal to the amount below the waterline. For example, if 75% of a block is below the waterline, its density is 0.75. Ice floats because of density. When water freezes, it expands. Just like the expanding air in the hot air balloon, water molecules in expanding ice spread further apart. The atoms in ice are not as tightly packed together as they are in the liquid phase. If we observe an iceberg, notice about 92% of the iceberg is below the waterline. This means that the density of ice is 0.92. Density facts. To learn how to measure the density of water, click Density of Water. To see a collection of all science videos, click All Videos.